Hello, ladies and gentlemen. My name is Arseniy Afanasenko. I am from Aligned Research Group, and in this presentation, I'll be talking about the value of unstructured data and show you the use cases we have in Aligned Research Group for processing those data. Our company is a multinational company. We have distributed team in several countries. We focus on data science, data engineering, artificial intelligence, and we have a number of successful stories on various fields. So I'll show you first. I will show you 3 use cases of successful processing of unstructured text data that the web is full of. And the first one, we call it automatic web page categorization. As you know, in the world of internet security, and especially in parental control systems, there's an urge for content categorization, and one would like to know what the web page is about even before the end user downloads it, to protect users from some undesired content. And the existing solution that is widely used, and it is de facto standard, is based on the lists of domains that agencies like Siren and Webroot create. And this solution is reliable to some extent, but it's also prone to errors because web pages are in many different languages, and sometimes people who work at the agencies, they just don't know the language of the web page, and they need to translate it to English and make some decisions which might be wrong. And also, the solution based on lists is not fast updating, and so if there are any changes, this solution reacts rather slowly. So what we did in Aligned Research Group, we created a categorization engine based on deep learning, based on linguistic background, that makes content categorization on the fly. You might think that just searching for some predefined keywords is enough. Well, keyword search works in some cases, but without manual check, the results are not reliable. And so we implemented a deep neural network that replaces keyword search. It doesn't react on some words that are not meaningful. It can be connected to different languages by using some linguistic layer, and when it fails to classify the text, so for example, if there is some topic that cannot be defined, the model indicates it, and so that page can go to manual categorization or or so there will be no wrong decisions and over blocking of pages in parental control systems. The second case is instant fraud detection. So in the world of internet security, there is so-called phishing, which is a technique that bad guys use to steal credentials, banking systems, or social networks using web pages or even entire websites that are very similar to the attacked sites. We will call them phishing targets. And the existing technique to mitigate it is implemented with security departments of banks or internet providers, and people report those pages, and security staff checks them and blocks them. And in the best case, it can take several hours to block such page, but for bad guys that's enough, because some victims can be caught by those web pages even within several hours. So the problem is to detect such fraud instantly based on some automatic detection system. And in ARG, we created a solution for that. So I will give you an example of a phishing link that a victim might receive, and the trick is that that URL address looks almost like the legal website in most cases. So for a human, if you are attentive enough, you will always see the difference. But for the machine, this difference is hardly measurable, and sometimes it's not straightforward to see that a link looks like one of the phishing targets, and so there is a need for some sophisticated model to capture the perceptual similarity between pieces of text which are URL addresses. And so our solution is based on a natural language processing technique, and it has a neural network inside, and so we can instantly detect potential phishing links which are suspicious to be malicious. And then there is a second stage. If the system detects that a link is might be mixed by a human with a legal website, and we know that some categories of websites are prone to be attacked, and that was the use case number one about web page categorization. So we know that banks, payment systems, social networks are first and most frequent targets to be attacked by phishing bad guys. So the final stage of detection is comparison between the page content, and this content is not static. So first of all, we are looking for some logos, some layout elements, that are typical to a phishing target domain. On this slide, I showed a screenshot with a site looking like LinkedIn, because as you might know, LinkedIn is phishing target number one. At the moment, it draws about 40% of phishing attacks all over the world. And so that's the way how the system developed by Aligned Research Group detects potential phishing links on the fly, and so we can help security agencies and the internet providers to do this detection quickly and to save people's money. And here is the third use case of dealing with unstructured data that we do in the ARG. It's about detecting groups of websites or not websites, but internet domain names, which is kind of blind classification, not based on web page content as in use case number one, but based on some hidden similarities. So again, the first problem that arises is that there are groups of domains not registered but by humans, but registered by some program, which might be a malicious program, or it might be not, but still there is some algorithm of domain name creation, and the problem is to detect the entire group and know all the domains that belong to this group, because if one of them is known to be a botnet, all others are botnets too. And one of the main information sources is again the domain name itself. So to detect groups of domain names which we have no idea about how they are created, we used a modification of a well-known word-to-vec model, which is widely used in natural language processing. And if you don't have an idea of what is word-to-vec, so here's some dummy example, like treating words as some mathematical objects or even arithmetic objects, like king minus man plus woman equals queen, or England minus London plus France equals Paris. And this technique seems to be, well, it looks simple, but it is quite sophisticated inside, and it can detect domains not created by just one algorithm, but it can detect multiple groups of domains created by the same algorithm. And on this slide, here's an example visualization, because in this use case, we don't take final decision of what the internet content is, but we rather help humans to identify similar groups of domains, similar clusters of data that need to be analyzed, but an engineer who works with the system doesn't need to analyze thousands of domains. He can do it with just one internet domain, and then generalize the findings over the entire group. Here you can see this visualization created with so-called T-SNE technique that can help bringing unstructured data to more structured and more easily interpretable. So we are proud of this achievement because it helped a lot with detection of clusters of domains and some clusters of malicious domains. So we spoke about dealing with unstructured data in form of text. Another form of unstructured data is multimedia content like audio and video data. And here I will present two use cases of dealing with such multimedia data. First of which is with virtual avatar. It's basically an engine converting text to video. So unlike a usual chatbot, you have a visual chatbot, and we think that the next generation of chatbots will be like that. So they will not only generate text, but speak with human voices and look almost like humans. And our solution, and you can see a promo video if you follow a YouTube link on this slide. Here, the mimic of a speaker is generated based on the text and put over and embedded into the video. So here it's a real person, real presenter, but the mimics that she produces is created by a deep learning model. We can switch to different languages and do an internationalization of content, such content like news, and also this solution is real time. So one of the achievements here that we are proud of is the speed at which this solution works on a standalone machine and in cloud. It works much faster than real time. So this was implemented for Sberbank, which is one of the largest banks in Eastern Europe, and it's a working solution. And the second use case, dealing with unstructured data in form of multimedia content, is a solution for surgeons, which is an augmented reality-based surgery assistance system. So it's self-explanatory on the slides, and you might have heard of similar solutions existing all over the world. And our solution was successfully adopted in 20 medical centers, and multiple surgeries have been made using this system. So in brief, the essence of this system is that a surgeon plans the surgery based on some MRI or CT scans, and in the course of a surgery, he knows exactly which organ is where, and how much space is left, or how much distance should be how much distance is left to the edge of an organ, for example, and so the surgeries are made less invasive, and less time is spent, and so we help people stay healthy. It's actually it's a large system developed by our company. It includes medical processing library, visual tracking system, and rendering system, and so it's just working. So that's just part of the portfolio of our company, and that's what is relevant to the topic of unstructured data. Thank you for your attention. You can find us in different corners of the world, and we will be happy to communicate with you and answer your questions. Thank you. Have a good day.